Hello, guys. A very warm welcome to each and everyone, those who are watching these videos. Hello, guys. Hello, Mayura. Hello, Aryan. Welcome. Okay, we are 2 minutes late. We are extremely sorry for the delay. I hope everyone can hear me, those who are watching this video. Let me just share the screen so that everyone can look at today's topic. Our today's topic is atoms and molecules. It is a very interesting topic which we are going to cover today. Atoms and molecules. We'll wait for 2 minutes for everyone to join this lecture so that everyone can. Yeah, you can hear me. Thank you, Aryan. Hi, hello. Hello, Swarna. Hello, everyone. Welcome to Letstute. So guys, for those who haven't subscribed to our channel, please do subscribe to our channel for more amazing videos and also live lectures for our videos. Please do subscribe and don't forget to press the bell icon to never miss an update from us. Also, we have courses on our website, that is www.letstute.com. So you can check amazing videos there. Yeah. This is a very interesting topic actually, atoms and molecules. Like if you really understand what are atoms and how they actually are, this can be a very interesting topic. Thank you, Aryan, for subscribing. Yeah. Thank you. So atoms and molecules. What is atoms and what is molecule? Today we are going to cover the basics of atoms. What are atoms? The history behind it, and some renowned, well-known scientists, those who have proposed atomic theory. So one of them is Dalton. We are going to talk about his atomic theory today. What he proposed. Yeah, thank you, Swarna. So let's quickly start with today's topic. So first of all, let's understand what is atom. Yeah. So for understanding atom, let's imagine if we were atoms. If we were this small as atoms, imagine how the world would be. Like we are very tiny and atoms are very tiny. We will discuss about atoms, what is the size of atoms, how are atoms. But before, let me just explain you what is atom. Suppose if we have an example, like if I have a chalk and if I go on dividing the chalk forever, if I go on dividing that chalk forever, as a kid, even you must have tried to crush the chalk. So what do we get? We get chalk powder out of it. Exactly. So we get chalk powder out of it. But if you take these chalk powder and if you try to smash them, you're not able to divide these chalk powders any further. Have you imagined why does this happen? Or if we take one more example, suppose bundi ka laddu. Bundi ka laddu are very tasty, right? So if we take bundi ka laddus and we try to crush them, we get bundis out of it, right? We get bundis out of it. And if I take that single bundi and if I try to crush it, it will be crushed. But there will be a point where it further can't be crushed, where it further can't be divided. Suppose if we take one more example of wood. If we try to cut the wood, we get sawdust out of it. And if we take that sawdust and if we try to make more smaller sawdust out of it or more smaller particle out of it, we are not able to divide those particles. Why are we not able to divide the chalk? particles or the bundi ka laddu particles or these sawdust particles? Have you ever thought why we can't divide these particles further? So this exact same problem or this question was asked like 500 BC, at time 500 BC, like around 2500 years ago. There were many philosophers who questioned these things and try to answer these questions. So one of them is this person, Maharishi Kannad. His name is Maharishi Kannad. He is an Indian sage, Indian philosopher at 500 BC. He said that if we take a padarth, please remember whatever I'm saying. If we take a padarth and if we go on dividing that padarth, what I just said is if we take a padarth and if we go on dividing that padarth, we will go to a point, we will reach a point where we further can't divide that padarth or particle. And Maharishi Kannad named that particle as Parmanu. What I just said is if we take a padarth and if we go on dividing that padarth, there will be a point where we further can't divide that padarth or particle. And he named that padarth or particle as Parmanu. So what does this Parmanu mean? Parmanu simply means, Param means ultimate and Anu means particle. That means the ultimate particle which further can't be divided. So Maharishi Kannad in 500 BC, he said that if we take a padarth and if we go on dividing that padarth, there will be a point where we further can't divide that particle or padarth. And he named that padarth as Parmanu. So what does Param means? It means ultimate. And what does Anu means? It means particle. So the ultimate particle which cannot be divided. Along with him, in the same era, there was a philosopher, a Greek philosopher. So this is a Greek philosopher, Democritus. And during that time in Greece, there was a person, Zeno. He asked a question that if we take a padarth or if we take an object and if we try to divide that object, will we be able to divide that object forever or will there be a point where we further can't divide that particle? There were many people who said that we can divide a particle or any object forever. Suppose if I take this object and if I go on dividing this object, I can divide it forever. There were many people who said these things, like we can divide a number forever. If I take a particular number, suppose 10, and if I go on dividing it by 2, I can divide it forever, like till infinity or negative infinity. But what is with matters? These are matters, right? This is a solid matter. So what are with matters? So if we take any object and if we go on dividing that object, there will be a point where we further can't divide that object. And Democritus was the one to name it as atoms. So during that time, he named that particle as atom. And atom is derived from a Greek word, atomos. And what does atomos means? Atomos simply means where A means not and Thomas means to cut. Please note these all points down in your notebook so that you can remember all these things. And these are really fascinating actually. So atom was derived from a Greek word atomos, where A means not and Thomas means cut. So that simply means that atomos word means that it cannot be cut. And atoms are indivisible. Atoms are the particle which cannot be divided further. But of course, as technology has grown, we can divide atoms into more further particles as electrons, protons, neutrons, and also them into quarks. But for now, we'll study as atoms are the smallest particle which cannot be divided. Atom is derived from a Greek word atomos, where A means not and Thomas means to cut. That simply means it cannot be cut. So if so why we were not able to divide the chalk particle further? The answer is because we had reached the smallest particle of the chalk, which is atom. Why was I not able to divide the chalk particle any further? Because I had reached the very smallest particle of that chalk particle named atom. So, where is atom? Where is atom? Why can't we see them? So atoms are present everywhere. So if I take this presenter as an object, in this atoms are present. If I take water, in that atoms are present. If I take air around me, in that also atoms are present. If I take myself, inside me atoms are present. So atoms are present not only in liquid, solid and gaseous, but also in living as well as non-living. Of course, you may ask question, how can atoms be inside us? As I was studying about atoms, I came across, like, I used to think that we are made up of cells. So cells are the smallest particle of us, and atoms are the smallest particle of any other matter. But it's not true. We are made up of cells inside which there are genomes, DNAs, and all these DNA strands are made up of atoms. It has adenine, then many other chemicals which are made up of atoms. These are elements. So atoms is present everywhere. Why can't we see them? Of course, why can't we see them? Because they are very tiny, they are very small. But when all these atoms aggregate together, or all of them collect together, we can touch, feel or see them. Like for this, suppose all the atoms came together to make a proper object, so that I can feel it, I can touch it, and even I can see it. Okay, so we saw that atoms are the smallest particle which cannot be divided, and the word atom came from atomos, and where the atoms are present everywhere. So how small are these atoms? We have been saying that atoms are very small, very small, very small, but in reality, how small are these atoms? Are they this small, or are they this small, or are they this small? Like, what is exactly the size of atoms, or what is the measurement in which atoms are measured? So atoms are measured in nanometers. Now, what is nanometer? For that, I will give you an example. Suppose if I have a scale, a 15 centimeter scale, and if I divide this scale into 150 million parts, like if I divide this 15 centimeter scale in 150 million parts, I will get a single atom. Isn't that like bizarre? That's a lot of numbers, a lot of parts in which I have to divide 15 centimeter scale. That means atoms are really very small. So the real size, or atoms are measured in nanometers. So the conversion factor of a meter to nanometer, a meter is around like, I don't know how much, like 2.5 feet or something. Like, we know how much meters are, but the conversion factor of meter to nanometer is, if I take 1 nanometer, I will have to take 10 raised to 9 nanometer to make 1 meter. Of course, the conversion factor goes like meter, then decimeter, then centimeter, then millimeter. Then after that comes millidecimeter, then millicentimeter, then micro, and then comes nano. So nanometer is really small. So atoms are measured in nanometers, which are really very small. The conversion factor is very important. Please note it down. 1 meter is equals to 10 raised to 9 nanometer. Get it? Okay, so let's quickly learn some important features about atoms. But before that, there was a person named Antonio Lavoisier. He was the one who changed the whole chemistry, or the whole the way we look at atoms. Till now, these all were the theoretical things, but he was the one to prove some amazing facts about atoms. He gave very important laws, the very two important laws, which are law of conservation of mass and law of constant proportion. We will be studying these two laws in this video. So what is law of conservation of mass? For that, he took an example. He performed an experiment in which he took a conical flask, and inside that he placed a test tube. Remember, the solution inside the test tube and the solution inside the conical flask are not mixing. They are separated. Okay. So for the first figure, as you can see in the first figure, there's a conical flask. Inside that there's a test tube. Inside the test tube there is calcium chloride solution, and inside the flask there is sodium sulfide solution. So these two are different solutions which are in which are separated, and if we weigh these solutions, we can see that it is exactly 323 grams. That is 300.23 grams. I'm so sorry, 300.23 grams. After that, if we take this apparatus and if we try to shake it, of course the solutions will get mixed and the chemical reaction will take place. But how will we get to know the chemical reaction has taken place? For that, if we look at the apparatus after shaking, we will get a white precipitate. As you can see in the diagram, it's written that calcium sulfide white precipitate. Calcium sulfide, a white precipitate will be formed. Now, what is white precipitate? It is powder. Powder. Yeah, it's powder actually. If we look at solution, there will be powder at the surface, at the base of the conical flask to symbolize that the chemical reaction has taken place. But what is important is that before the chemical reaction, the exact weight is equal to the after chemical reaction. That simply means that the weight before the chemical reaction and the weight after the chemical reaction. That means the mass of before chemical reaction, mass of after chemical reaction is exactly equal. This is the point which we are supposed to note. The weight, the mass before the chemical reaction and the mass after the chemical reaction is constant. This is the law of conservation of mass. The statement for law of conservation of mass is, oh, before that, let's take one more example. I have one more example if you haven't understood that example. So if we take a rice bag, a 2 kg rice bag, and if we take 1 kg wheat ka bag, and if we try to mix both of them, we will get a 3 kg ka mixture. Remember, the weight is constant, like the weight on the reactant side and the weight on the product side. Of course, what is reactant, what is product? Reactants are the before chemical reaction wala elements and or the compounds, or and products are the after chemical reaction wala products. Okay, so I have laser. Okay, so these rice and wheat are considered as the reactants, and the mixture will be considered as the product. But in the previous slide, wait a minute. Okay, okay, it's lagging a bit. Wait, guys. Yeah, in this picture, as we can see that NaCl2 and Na2SO4 are the reactants. But what are the products? After reaction, whatever we get is the product. So calcium sulfide and sodium chloride, these are the products. Okay, so reactants are before the chemical reaction and the product is what we obtain after the chemical reaction. So the weight or the mass of the reactants and the products will exactly be equal, is my point. So what does the law says? The law says that mass can, I haven't mentioned. So the statement is mass can neither be created nor be destroyed in a chemical reaction. Please note down this definition. This can come for your exams. Law of conservation of mass. The definition is Mass can neither be created nor be destroyed in a chemical reaction. Like if a chemical reaction takes place, the mass can neither be created nor be destroyed. But what is the law of constant proportion? If we take the second example, the second law, we will take an example of water molecule. For water molecule, we have H2O and oxygen. That is, I'm so sorry, hydrogen and oxygen, that gives us water. These are the two elements which we are going to use. These are the two molecules or compounds which we are going to use to make water. As you can see, 1 gram of hydrogen and 8 grams of oxygen gives us 9 grams of water. But if we take 9 gram of water, we will get exactly 1 gram of hydrogen and 8 grams of water, 8 grams of oxygen. What does this mean? This simply means that hydrogen and oxygen reacts in the proportion of 1 is to 8. If you take any water, if you take a salty water or a pure water, the proportion in which the hydrogen and oxygen are mixing will be exactly equal to this proportion. It is universal. Like hydrogen and oxygen will mix in this ratio only. Why does this happen? We will see it in the later videos. But for now, we have to understand that the proportion will be constant. The proportion will be 1 upon 8. Suppose if we take another example of ammonia, suppose N and H3, that is nitrogen and hydrogen, 3 atoms of hydrogen. So NH3 is the formula for ammonia. So the ratio in which those elements mix are 14 and 3. 14 is to 3 is the ratio for them to mix. So they will have a constant proportion. So the statement for it is, in a chemical substance, the elements are always present in definite proportion by mass. As in the previous example, we saw that 1 gram of hydrogen mixes with 8 grams of oxygen. The proportion will always be constant, but according to their masses. Okay, so this is law of constant proportion. We saw law of conservation of mass, and this was law of constant proportion. Law of conservation of mass states mass can neither be created nor be destroyed in a chemical reaction. But law of constant proportion states, in a chemical substance, the elements are always present in definite proportion by mass. Okay, let's look at this person. This person, during that time, these were some laws, but it was not stated properly, or it was not available to each and everyone. There was not a uniform book in which people can refer the book, or there wasn't a theory which people can refer. So during that time, there was a requirement or need for a theory which will be universal for everyone, which everyone can follow. So this person, Dalton to the rescue. Of course, it's not his name, but Dalton to the rescue. Dalton was the person to bring his atomic theory. So his atomic theory is Dalton's atomic theory. In this theory, he has stated what were the properties of atoms and how we can easily state or understand what is atoms. He stated very important 6 statements in his Dalton's atomic theory, which is very important. Please note it down as you check the slides. The first statement he made, that atoms are very tiny. The atoms are very tiny. So his statement was, the matters contain a very tiny particle named atoms. Atoms are very tiny. So why are they tiny? Because they are measured in nanometers, and we have discussed that atoms are very, very small. So first statement that he made was, atoms are very tiny, or the smallest particle in matter is called atoms. This was what he stated. The second thing what he stated was, atoms are indivisible. So what we have discussed, that Atoms are the smallest particle which cannot be divided. The particles which cannot be divided are termed as indivisible. Okay, so atoms are indivisible is the second statement which he gave. The third statement which he gave was atoms of same element have same mass and chemical property. So suppose if we have two atoms of helium, He means helium, so these are two atoms of helium. If we try to measure their size, both are of same size. If we try to weigh them, both will be exactly of same mass and they will have exactly same chemical property. So what does this mean? If we have identical atoms, their mass and their chemical properties will be exactly same. But in place of two similar helium atoms, if I take one helium atom and one neon atom, they both are different elements, they both are different atoms, remember. So they will have different mass and chemical property. This was stated by Dalton. So as we can see, they both have different size. Helium is a bit smaller and neon is a bit bigger than helium. So they both are of different size, and with that they will have different mass and also different chemical properties. So this was stated by Dalton in his atomic theory. This was the fourth statement which he gave. The fifth statement was elements combine in the ratio of small whole numbers. That simply means that the elements which are mixing will be in whole numbers. They cannot be half hydrogen and half oxygen. As we can see in the equation, two hydrogen atoms and one oxygen atom is used to make H2O. Two hydrogen atoms and one oxygen atom is used to make H2O. We cannot have half hydrogen atom and 3/4 oxygen atom. Why we cannot have half hydrogen atom and 3/4 oxygen atom? Because atoms cannot be divided. Of course, if atoms cannot be divided, we cannot have half ratio of them, right? So they will be combining in the whole numbers. What are whole numbers? Either it can start from 0, 1, 2, 3, 4, 5, but it will be small comparatively. So elements will combine in ratio of small whole numbers. This was the fifth very important point, and the sixth one is a bit tricky, but we will try to understand it. It states that the relative number and the kind of atoms are constant in the given compound. Now what does this mean? Suppose if we have a beaker full of full of water, sorry, if we have a beaker full of water, and if we try to scan all the sections of this water, like the first part of water, the second part of water, the third part of water inside the beaker, as I said, all the water like whether it's salty water or fresh water, doesn't matter, the composition of the water will be H2O, because water is H2O. So if we try to scan this whole water compound, we will find that it gives relative number and the kinds of atom are constant. What does this mean? It simply means that the relative number, that is two hydrogen and one oxygen, and the kind of atom, that is water compound, water molecule, water molecule, water molecule, water molecule, this is repeated in the given compound. That simply means that in the whole compound, it will be made of homogeneous compound or molecules. Okay, so these were the very important six laws of Dalton's atomic theory. So that's it for this session. So let's quickly revise everything, whatever we have seen. Yeah, so if there's any question, you can ask it in the chat box. Let me just address a few kids, those who have been writing in the chat box. States that matters can neither be created nor be destroyed in a chemical reaction. Very good, Para. Yeah, Padarth is a Hindi name for substance or objects, as we can say. Very good. Yeah, so Padarth are the smallest indivisible particle which cannot be divided. And what is Padarth? Padarth is a Hindi word for objects or matters. Okay, so whatever we have discussed, let's quickly discuss them. So first, we had discussed that atoms are the smallest indivisible particle which cannot be divided. There were few Indian sage and as philosophers and Greek philosophers who has stated them. One of them was Maharishi Kannad, and the second was, let me just make myself bigger. Okay. So yeah, so two very important persons were Maharishi Kannad and Democritus. After that, there was Antonio Lavoisier. He was the one who gave law of chemical combination, the very two important laws, law of conservation of mass and law of constant proportion, where law of conservation of mass means mass can neither be created nor be destroyed in a chemical reaction, and the second part states that the proportion will always be constant by mass. Remember, it will be constant by mass and not by the number of atoms. Both are different. Number of atom is different, and the mass the element gives is different. The mass in which it reacts is different. Okay, so this was about atoms, but after that there was a very important, or there was need for a universal theory. So Dalton to the rescue. So Dalton to the rescue came with his Dalton's atomic theory. So Dalton's atomic theory had very important six laws. So the first law was atoms are very tiny. Atoms are very tiny because they are very tiny, of course they are very small. So second statement which he made was atoms cannot be divided, they are indivisible, nor they can be created nor they can be atoms can never be created nor be destroyed. This is a very important part which I guess I didn't say, but it is very important. As matter mass can never be created nor be destroyed, same is for atom. Atom has some mass, therefore it cannot be destroyed or be created. Okay, so this was the second part. The third part was, can anyone tell me what was the third part? What was the third part? Anyone who can just post it in the chat box? What was the third statement which was stated by Dalton? The third and the fourth goes in hand. Yeah, so atoms of same elements will have same atomic mass, will have same mass and same chemical property, but different atoms will have different mass and different chemical properties. These were the third and the fourth laws which are very important. The fifth law, which was, is that atoms or elements combine in the small ratio, or they combine in small whole numbers. We cannot have half hydrogen atom or half oxygen atom. Remember, we cannot have half hydrogen atom or half oxygen atom. They will combine in small ratio of whole numbers. And the sixth statement, which is very important, that the relative number and the kind of atoms are constant in the given compound. That simply means if we take a compound and if we try to scan the whole compound, we will have same molecules or same elements or same compounds, yeah, molecules, that's it, if we try to scan it. So does anyone have any doubt related to atoms and molecules? You can ask it in the chat box, but before that let me just say that you can check our website, that is www.letstute.com, for more amazing videos, more interesting videos on science as well as math. You will find very amazing videos there. If you guys have any doubt, please post it on the chat box. I'm ready to address it. We will close this live session in 2 minutes. Like, so before that, if you have any question, please type it down so that I can address it. I guess you guys don't have any doubts. It's okay if you try to recollect each and everything. It will be amazing. If you have enjoyed this video, then please smash a like on the like button. Yeah, and you can subscribe to our channel and be tuned for more amazing videos and live lectures on Letstute. Yeah, guys. So I don't think so. There's any doubt related to this concept. Okay, so no problem. We will catch you all later with more amazing live sessions. Be tuned. Yeah. So before that, if you haven't subscribed to our channel, then do subscribe and don't forget to press the bell icon. We have website called www.letstute.com. You can check amazing videos there on math as well as science, as I have said. Thank you, Sonali. That was a nice session. Thank you. The comments really makes us motivated. Like, it motivates us. Yeah. Thank you. That's it for this session. Thank you, guys. Be tuned, and we are ending this lecture. Okay. Bye, guys. Bye.